Hello everyone. So let's discuss what's linear regression. So before jumping to linear regression, let's understand what are dependent variables and what are independent variables. So in first of all, we have to understand that in linear regression, we always have one dependent variable and there could be several independent variables, or it could be one independent variable. So what is a dependent variable? So dependent variable is a variable which we are going to measure. For example, let's understand we want to calculate the impact of weather on daily sales. So here, sales is going to be dependent variable and the weather is going to be independent variable. So what definition says, an independent variable is a variable which we use to calculate the dependent variable. So let's understand what linear regression is. So linear regression is a common statistical data analysis technique. Using linear regression, we can determine or measure the extent of linear relationship between the dependent variable and one or more independent variables. We have two types of linear regression. The first one is simple linear regression and the second one is multiple linear regression. So when we have one independent variable, then it is called simple linear regression. When we have more than one independent variables, it is called multiple linear regression. So next is data considerations. So in linear regression, always remember that dependent variable should be continuous measurement scales. Like example, we have 0 to 100 test scores, and independent variable, it could be continuous or it could be categorical. So categorical means we have categories in data like male versus female, and continuous is when we have continuous measurement scale like in meters, kilometers, or we have one number. So it depends on you how you take what kind of data you guys have. So always remember to keep dependent variable as continuous, and independent could be anything, categorical or continuous. So let's understand the real life example of linear regression to make it more clear. So suppose you want to go to a trip and you want to analyze like how much money you're gonna spend on your trip, and what you have is you have all the data from your previous year trips and how much you spent on oil. So what you're going to consider in this is you're going to consider how many miles you traveled last year and what was the price of the oil last year. So our linear regression, we can use linear regression to solve this problem. And also this is the simple formula, or you can say equation, we can fetch out of it. So this is so here is like we're gonna use how many miles we have covered and what was the price of the oil, and there are we will be having some coefficients associated with each variable and error. So we're gonna understand these coefficients and these dependent and independent variables using real data using Python. So let's move to that. I'm using a Jupyter notebook for running the code. So let's understand the data. So data which I'm using is like it's a real estate agent data where he or she has average area income, average area house age, and average area number of rooms, number of bedrooms, area population, price, and address. So these are the columns we have in the data set. So first of all, we have to import the libraries. So just write it down, import pandas as pd NumPy as NP, Matplotlib if you want to do exploratory data analysis using graphs, and Seaborn if you want to use any visualization, and Matplotlib inline. So first of all, my dataset name is USA Housing. So I'll be reading using pd.readcsv function, and I'm gonna put it in a variable called USA Housing. So my next command is USA Housing.head. This is gonna return first 5 records of the data. So you can see first 5 records of the data. So my next is USA Housing, or the dataset name or the data frame name .info. So it's gonna give how many records I have, how many nulls I have, what's the data type. So it's gonna describe your data. It's gonna basically give you information about your data. So next is describe. So describe is a very useful command where we can get the description of the data, like what's the standard deviation of each column, what's the mean, what's the count, and like very common statistics it's gonna give in the using describe method. So we can see what columns we have using our data set variable dot columns. It's gonna return us all the columns of the data set. Next, here I have used heat map to check what's the relation what's the correlation of my columns. So here you can see average area income has some correlation, and more the darker the color, more is the correlation. So here you can see area average area income, and average area income is the darkest one. Why? Because it's the same data, so it has the highest correlation. It's very common. So this is not our focus point, so we have to see this, like average area income and price, average area house age and price. All these have correlation. So it shows us that we can use linear regression here. So let's train our linear regression model. How we do this is we have our data set, and one is going to be dependent variable and other are going to be independent variable. So here I have chosen the price, like what price is the house is going to be depend on all the columns it has, like what's the average area income and the house age and the number of rooms. And using these variables, I'm gonna decide what's going to be the price of the house in that area. So first of all, we have to divide our data into 2 parts. The first one is training set and other one is the testing set. So training data set, or our training part, we use it to train our model, and test is to validate or verify whether how accurate our training model is. So since linear regression is supervised learning algorithm, machine learning algorithm, so we already have few columns with the output, or we can say we already have the output to verify our model. So the first of all, what we're gonna do is we're gonna import test train split from the library sklearn. So from sklearn.model selection, we're gonna import train and test split. What we're gonna do is we're gonna divide our data into training set and test set. So each set has one dependent variable and several independent variables. So we have xtrain as our training data set, but what it is here, we see like this is a independent variables. So these are independent variables from training set. This is from from the testing set, and y is our output or dependent variable from training, and similarly this is from test set. So what method we're gonna use, what function we're gonna use? We're gonna use train test split x, y, and test size is 0.4. It shows like what's the percentage of the train and test split. So it's gonna be 0.4, like 40%, 40-60. So next is creating and training our model. So similarly, as we have imported here our library, we have to import linear regression from which library? sklearn.linear model. We're going to import linear regression, and next is we're going to fit our model. So we're going to use the training dataset and fit the linear regression model. So we are using linear regression as lm.fit xtrain x ytrain. So now this is like really simple, only 3 lines of code. Our linear regression is already implemented, and now we have to evaluate the model. How we're gonna evaluate is we're gonna check the coefficients. So we're gonna convert the coefficients into data frame using pd.dataframe, and lm.coef underscore is gonna return us the coefficients. So we're gonna create the data frame from coefficients and our columns, and give the name of the column as coefficient. So let's understand what these coefficients mean. So for example, average area income coefficient is 21 point something. What it means is if we increase a 1 unit of average area income, it's gonna increase our price by $21.52. Similarly, if we're gonna increase 1 unit of house age, average area house age, it's gonna increase our housing price to this much. So this is not the real data set, so it's kind of weird what the result shows. So this data set, it's just for an example. So let's see. So predictions from our model, we can use lm.predict. This is x test. We're gonna verify our predictions, and we're gonna create a scatter plot from by test and predictions. So you can see the scatter is quite linear. This is like it's very rare that it's gonna happen with the real data, but for understanding it's a good example. So let's understand so let's move on to regression evaluation metrics. So like here we can see, so this is the predictions. It contains all the values which our model is predicting, and these are the real outputs which are already inside the data. So here we can say it's quite linear, but we have metrics to evaluate our regression model. So here are 3 evaluation metrics for our regression problems. So the very first one is mean absolute error. It gives the absolute values of the error. So this is the error, and this 1 by n shows that we are going to take its mean. The next is mean square error. We're gonna square the error and then find out its mean. And the root mean square is just taking the under root of mean square error. So for any regression problems, we have to minimize these values. For all these errors should be less to make our model good. So how are we going to calculate using Python? We have to import matrix from sklearn, And what we're gonna do is from matrix dot mean absolute error is the function we're gonna use, and from there it's gonna take two parameters. The very first one is y test and the prediction. The values of the dependent variable which our model has predicted is in predictions, and the y test is the actual output we have, the actual price we have, or actual independent variable we have. So similarly, we can use mean square error for MSE and mean square, and for the root mean square error, we have to just use numpy's sqrt function, that is square root, and here you go. So it's gonna print all the errors for us. These values are quite high, but because we are not using the real data, it's just one example. Thank you very much.